In this fourth section of the Module 7 lecture, we're going to talk about the sampling distribution of the proportion, and this is covered in section 7.5 and 7.6 of the textbook. All right, just to clarify, the proportion is a relative frequency for a category, or in the case of a binomial experiment, is the proportion of successes. So the population proportion, or what we call the probability of success in chapter 5 when we talk about the binomial probability distribution, is defined as the number of successes in the population divided by the total number of elements in the population. And the sample proportion, we call it P, and is the number of successes in the sample divided by the total number of elements in the sample. I wanted to clarify that the book uses the letter P instead of pi and uses P hat instead of P. I'm staying with the pi and P notation because we started to use that all the way back in Module 3 and Module 5. So please note that discrepancy in symbols between the textbook and what you find on the slides. All right, let's look at an example just to illustrate how we calculate these proportions. So in this very simple example, we have a total of 789,654 families that live in a city, and of those families, 563,282 of them own homes. Now, a sample of 240 families is selected from this city, and 150 of them own homes. So what we want to find is the population proportion and the sample proportion of families who own homes. So here's the population information, and here's the sample information. So I think you can imagine how this goes. All right, so the population proportion of people who own their homes is the number of families in the population that own homes divided by the total number of families in the population. So that proportion is 0.71. In the sample proportion, we have the number of families that own homes in the sample divided by the total number of families in the sample, and that gives you 0.66. So here's an example to illustrate how you calculate these proportions. And also remember that the sample proportion P is the statistic that estimates the population proportion. This is very important because whenever we don't know pi, we're going to replace it with this sample proportion P. All right, so what is the sampling distribution of the sample proportion? Well, we know it follows a binomial probability distribution with the mean equals to pi and the standard deviation equals to pi times 1 minus pi divided by the sample size, and you take the square root of that, and that gives you the sample proportion of the sampling distribution of the proportion. All right, so now here we have the two key characteristics of the sampling distribution of the proportion. Its mean and its standard deviation. So obviously the next question is, well, what is the shape of the sampling distribution of the sample proportion? Well, we go back to the central limit theorem for the sample proportion. And this central limit theorem for the sample proportion, it says that the sampling distribution of the sample proportion is approximately normal as long as the sample size is sufficiently large. What is sufficiently large? Well, you remember from chapter 6 when we approximated the binomial distribution with the normal distribution, we saw that the sample size times the probability of success must be at least 5, and the sample size times the probability of failure must be at least 5. Now, when pi is not known, we're going to replace it with its estimator, the sample proportion. So if the sample size times the proportion, the sample proportion that is at least 5, and the sample size times the sample proportion of failure is at least 5, then we can approximate the sampling distribution with a normal distribution. So if you're dealing with the sample proportion and you want to find what is the probability distribution or the sampling distribution of the proportion, you need to verify either of these conditions to ensure that the sampling distribution of the proportion is normal. All right, so again, as I said in the previous slide, as long as these conditions are met either when pi is known or when it's replaced with a sample proportion, as long as these conditions are at least 5, then we can safely assume that the sampling distribution of the proportion is normal and it has a mean of pi and a standard deviation of the square root of pi times 1 minus pi divided by the sample size. So this tells us that the sampling distribution, we know its mean, we know its standard deviation, and we know if those conditions are met, then we have a normal distribution. So that's telling you that we're going to follow what we learned in the second part of module 6, whenever we approximated the binomial distribution with a normal distribution. And here's an example. So it was reported in 2014 that 73% business travelers stated that hotel location was most important when determining where to stay when they were on the road. So a random sample of 200 business travelers in 2014 were asked what was the most important factor for choosing a hotel when they were traveling on the road. So the question is, what is the probability that more than 80% of them stated that the hotel location was the most important factor when determining where to stay when they were traveling? All right, so as we learned in chapter 6, the very first thing we need to verify is whether or not this is a description of a binomial experiment. And you see that it is, because 200 travelers were identically interviewed. They're not saying it, but you can imagine that they were asked the same question. There are only two outcomes. Either they said the location is the most important factor, or they said that some other factor is more important. The probability of success, that of saying that location is more important, is constant through each interview, and therefore the complement, which is 1 minus pi, must be constant for each interview. They don't say it, but we could assume that the interviews were conducted independently. The random variable counts the number of successes, so the number of times the traveler said the location is most important. So I think we can safely argue that we have a binomial experiment. So given that, the next step is to verify if we can say that the sampling distribution is normal. So in this case, since the sample size is given and pi is known from the description of the problem, then we can verify that these two conditions are definitely larger than 5. So then we can say that the sampling distribution of the proportion is normal with a mean of 0.73 and a standard deviation calculated in this way of 0.0314. So now, given this information, we can proceed to calculate the probability that more than 80% of the travelers said that they prefer location when selecting a hotel. So that means that we want the probability that the sample proportion is bigger than 0.8, which is the same as the complement of 1 minus the probability that the proportion is less than 0.8. Now we're using less than because since we're going to be using table 4 to calculate the probability, because the sampling distribution of the proportion is normal, then it only gives us probabilities to the left of the value. Therefore, we are going to use the complement. All right. So now that we know the sample proportion of being 0.8, then we calculate the corresponding z-value. And the proportion is 0.8. The mean, as we determined in the previous slide, is 0.73. And the standard deviation of the sampling distribution of the proportion is 0.0314. We carry out this calculation and we obtain 2.29. So if you go on to table 4 and look for this z-value, which you need to round it to 2 decimal places, so for z of 2.23, you find a probability of 0.9871. So we can say that the probability that the proportion of travelers say that the location of the hotel is most important is bigger than 0.8 is the same as 1 minus the probability that z is less than 2.23, which is using 1 minus that quantity that we found in table 4 is 0.0129. So once we have found the desired probability, we need to explain that result. So we can say that the probability that more than 80% of the 200 travelers that stated the hotel location was most important when determining where to stay on the road is 0.0129 or 1.29%. So again, this is an example of how you can use the sampling distribution of the proportion. When we can say that it is normal, you can see how you can use it to calculate probabilities. Again, I'm not going to assign you problems like this for homework because this aspect is going to be used in a more important way when we construct confidence intervals for estimating the population proportion, as we will do in subsequent sections of this module. I will stop here, and in the next recording, we'll talk about the estimation of population parameters. So this is already in chapter 8 in the textbook.